Everyone, in today's video, we are going to be working through your textbook. I am on page M1-269 right now, M1-269. Awesome. So hey, what we're going to do first is this warm up. The goal for this video is really be able to calculate the average rate of change in a polynomial function. So for these three functions given, determine each function's average rate of change for the interval 0, 2. This means, well, hey, on a polynomial, right, we know that we can maybe like increase, maybe decrease, go back up again, do some pretty crazy movements like that. So what we're looking for in average rate of change is, so to get from this point to this point, on a straight line, essentially, how did we get there? We know there's this curve here, so it doesn't increase by exactly the same amount every single time. But on average, what are we increasing by? Not the most difficult thing to do again, but we can do this as long as you remember how to find the slope of a linear function. So anyways, let's get to this first question here. F of x equals 1/2 x. Determine that function's rate of change for the interval 0, 2. So to start this off, let's evaluate the function at these two locations. So this is not like an ordered pair. This is telling you what the x intervals are. So we're going to do f of 0 equals 1/2 times 0. So this should be pretty easy for us. F of 0 is equal to, well, hey, 1/2 times 0 is just going to be 0. And then we'll plug in 2. So f of 2. F of 2 equals 1/2 times 2. So again, I'm just evaluating. I'm just plugging in these x values into these function rules. So f of 2 is equal to, well, hey, half of 2 is 1. All right, fantastic. So if we keep on moving through this, the average rate of change is f of the second output minus the first one. So we'll just do f of a for that. And then it gets divided by b minus a. So this should look pretty familiar to you. It's a lot like, again, slope from Algebra 1. We're doing the difference in the y values, the change in the y values, divided by the change in the x values. That's really all this amounts to, and it's just the notation that they use for this. So now that we have all this stuff figured out, we can figure out the average rate of change. Like f of b, f of the second output, the second thing that we calculated was 1. 1 minus the output from what we first plugged in. The output here is 0. That's all going to get divided by. So what is the actual value of a? What was the value of the first thing that we plugged in? And this is the value of b, the second thing that we plugged in. So we'll go 2 minus 0. 1 minus 0 for 1, 2 minus 0 for 2. There we go. Finally, we got the average rate of change. On average, our function increased by 1/2. It essentially goes up 1 over 2 on average. It doesn't do that exactly, but again, we're just looking for the average change. Kind of what's the straight line distance rather than the curve distance to get from one point to the other. Okay, let's do another example, and hopefully that'll make it sink in a little better. So question 2, g of x equals 3x squared. Okay, so if you remember the formula that I gave you to do this, we need to figure out the outputs first. So for this function as well, let's plug in these x values. So g of 0 is equal to 3 times 0 squared. Start to simplify this. 0 squared is 0, and 0 times 3 is 0. So this one we've also got a 0. Now let's plug in our other term, g of 2. G of 2 equals 3 times 2 squared. 3 times 2 squared, okay. Break this one down a little bit. Hey, we know that 2 squared is 4, and we know that 4 times 3 is 12. So to get the average rate of change, it's the difference in these outputs, so the difference between 12 and 0, divided by the difference in the inputs, these things that I was plugging in. So The average change, average, I'll just do average rate of change. Average rate of change is equal to, so again, it's this second output value minus the first output value, and then those get divided by the things that I was plugging in. So 2 minus 0. 12 minus 0 for 12, 2 minus 0 for 2, and we get an average rate of change of 6. Maybe I can try to graph this one a little bit. Hopefully make it like a little bit more clear exactly what it is that we are finding. So we know that when I plugged in 0, the function spit out 0. So I've got a point here at 0, 0. And, you know, like we go over 1, and we go over 2. So when I plugged in 2 to this function, when I plugged in 2, the function spit out a 12. So I go look all the way up here to 12. And then this is a quadratic, so it's going to reflect and be on this side as well. So that's pretty well what the function looks like. Just pretend I went through 12 right there. Okay, so we're not going up by exactly 6. Like we don't go over 6 and then over 1 and then over 6 and over 1 to get to this point. That's not the rule that we're following exactly. But again, the average distance or the average rate of change between this point and this point, the average rate of change, on average we go up 6 units and over 1 unit to get there. So again, that is what we're trying to find. Let's move on to that last example problem here, the last one problem. It's h of x equals 2 to the power of x. So we're doing an exponential function this time. No difference though. We still need to plug these things in. So we'll do h of 0 equals 2 to the power of 0. And then we'll do h of 2 equals 2 to the power of 2. All right. Hey, so for this one, h of 0. So if you remember this, like these exponent rules, anything raised to the power of 0 is actually 1. Anything raised to the power of 0 is 1, not 0. So when I plugged in 0, the function spits out 1. And then over here, when I plugged in 2, the function spits out, function is going to spit out 4. So if we start to do that formula, we need to find the difference in these outputs. Average rate of change is equal to 4 minus 1 divided by 2 minus 0. 4 minus 1 for 3, 2 minus 0 for 2, and that's it. On average, we go up 3 units, over 2 units. You can make that a decimal if you really want to, 1.5. Okay, that is really the goal behind the average rate of change. You need to specify an interval, find the outputs that correspond to these x values. So you plug in these things, you plug in the x values to get the y values essentially. And from there, this is exactly like rise over run or slope that you did in Algebra 1. So if we continue for just a bit in your textbook, let me delete this stuff and get rid of that. All right, so we'll go down to activity 5.2. There's a nice first example there on page M1-274. They're doing the average rate of change between 3.25 and 4.25. So it's just like what we were doing. You need to evaluate the function first, plug in those values, see what comes out as a result of those values, do some subtraction, some division, and that's really it. Fantastic. There's a modeling problem there. You can try on your own if you want to. So anyways, that's how you do the average rate of change. Thanks for watching, guys. See you in class. Bye-bye.